Alright, so let's take a look at these solving trig equation problems. These are going to be non-GDC questions, so you cannot use a calculator to solve these problems. Okay? So let's take a look at 1a here. So 1a, we're given all this information, and they tell us to find f composed g of x. Right? So we're trying to find f of g of x. Now we're given that g of x is equal to 2x. So now g of x we know is 2x. So basically we're just going to take 2x and plug it into the f function wherever there's an x. So the f function here, we have root 3 times sine. Now instead of x, I replace it with 2x plus cosine. Now instead of x, I replace it with 2x. Okay, so this would be our answer for 1a right here. Root 3 times sine 2x plus cosine 2x. Okay, let's take a look at 1b now. So 1b, we have, now they're saying f composed g of x is equal to this. So we know f composed g of x is this value right here. So we can set this equal to 2 times cosine 2x. So we have root 3 times sine 2x plus cosine 2x, right, is going to equal 2 times cosine 2x, right? I see like terms here, so I'm going to minus cosine 2x on both sides. So I get root 3 sine 2x is going to equal cosine 2x. And then I realize that, well, if I divide by cosine 2x on both sides, this would become tangent. So that's what I'm going to do there. I'm going to divide by cosine 2x on both sides. Right, so then I'm going to end up with root 3 tangent 2x is equal to, this will give me 1, right? And then divide by root 3, so we're going to get divide by root 3 on both sides. So we get tangent 2x is equal to 1 over root 3. If we rationalize this, that would give us root 3 over 3, right? So now we need to go back to our unit circle. So first of all, where is tangent positive? Tangent is positive in quadrant 1 and quadrant 3. And then also, when is tangent root 3 over 3? Well, that's when we're dividing by 6. So we have pi over 6 and 7 pi over 6 as our angles from the unit circle, right? So now let's solve for x here. So we're going to have 2x, right, is equal to, we'll start with this first value here from the unit circle, pi over 6. Now, since you have a number being multiplied with x, remember we're going to have to add the plus pi here because pi is the period for tangent, okay? And then when you divide by 2 here, or multiply by half, so when you multiply by 1/2 here to get x, you have to multiply this by half. So we're going to get pi over 12 plus pi over 2, okay? So that means that our first solution is going to be pi over 12, right? And then we're going to add pi over 2 to get more solutions, all right? And we have to stay within our interval. Now remember the interval they gave us, you always have to pay attention to the interval when you're solving these trig equations. The interval that we're given is from 0 to pi, so we don't want to go over pi, okay? So pi over 2, if I get common denominator, right? So pi over 2, if I get common denominator, that's the same thing as 6 pi over 12, right? That's equivalent to pi over 2. So if I add 6 pi over 12 here, I would get 7 pi over 12. Now this is still less than pi, so that's fine. Now if I add another 6 to this, right? If I add 6 to 7 pi over 12, I would get 13 pi over 12. But this is more than pi, so this goes over our interval. So I know that I don't want this solution, right? So we're not going to count this guy. So I know that we've got pi over 12 and 7 pi over 12, okay? So I'm going to do the same thing with the 7 pi over 6 now. So we have 2x is going to equal, we have 7 pi over 6 plus pi. So we multiply by a half here, multiply this by a half, we're going to end up with x is equal to 7 pi over 12, which we already found from this first part here, plus pi over 2. So same thing, pi over 2 is the same thing as 6 pi over 12. If I add 6 pi over 12 to 7 pi over 12, that's going to give me 13 pi over 12, but that's over our interval, okay? So we're not really going to get any more solutions from this. So we know that our two solutions that are in the interval is pi over 12 and 7 pi over 12, okay? All right, so let's take a look at the next problem here. So part A says show that this is equal to this. So it looks like if I just get common denominator here, right? So if we get common denominator, if I have 2x minus 3 minus 6 over x minus 1, if I just get common denominator here, which means I need to multiply the top and the bottom here by x minus 1 and x minus 1, right? So basically that's going to give me 2x squared, right, minus 3x minus 2x plus 3, right, minus 6. So if I simplify all this, I'm going to end up with 2x squared minus 5x minus 3 all over the common denominator x minus 1. So basically I've shown this right here. Okay? So this would be what you need to show for part A. Alright, so let's take a look at part B now. So part B says hence or otherwise solve the equation 2 sine 2 theta minus 3 minus 6 over sine 2 theta minus 1. Right? So basically what they've done is you kind of have to think of this part right here. Right? Think of it as x, right, is equal to sine 2 theta. So you notice if you replace this right here with x, if you replace this right here with x, you would get basically what this is right here. Okay? And we know that this is equal to this, right? So basically what this means is I can take, wherever there's an x here, I can replace it with sine 2 theta and solve this, okay? So this right here, so this problem right here, basically is equivalent to this, right? So I can say, okay, 2 times sine squared 2 theta, because the x is being squared here, minus 5 times sine 2 theta. Oops, let me put a theta there, not an x. And then minus 3 all over sine 2 theta, right, minus 1 is equal to 0. Okay, so that's the first thing you need to recognize, right? Anytime IB says the word hence, that means that you should use something you've done previously to try and help you solve this problem. Okay? So now, if we set this equal to 0 and we're solving, basically the denominator is going to be irrelevant because if I multiply both sides by the denominator, this is going to basically go away, right? It'll divide out, and this will still be 0. So basically what I'm really solving for is just 2 sine squared 2 theta minus 5 sine 2 theta minus 3 is equal to 0. So basically this is what I'm solving, okay? So now it's up to you. For some students, they feel like a substitution is easier for them to do, right? So if you recognize this as a quadratic, you can just factor it. Some people may feel that if I do a substitution, right, for example, if you say u is equal to sine 2 theta, this would be basically 2u squared minus 5u minus 3 is equal to 0, and then they can factor this easier. So if you need to do this substitution, that's fine. If you don't need to do the substitution, that's fine. So it's really up to you. So basically you would end up with 2u here. All right, so we're factoring this. This would be u, and then minus 3, and then plus 1. All right, so double check, everything works out. This is negative 6, positive 1. We get negative 5. Multiply here, we get negative 3. So we factored correctly. So now that you've factored it correctly, you want to plug back in the u, right? So basically, or actually you could even just solve this first. We know u is going to equal negative half. We know u is going to equal 3, right? So now that we know u is sine 2 theta, so we have sine 2 theta is equal to negative half, and we have sine 2 theta is equal to 3. Okay, first of all, we know this one here is going to be undefined because the sine of some angle, right, needs to be between -1 and 1. So we know this here is undefined already, right? So looking at the unit circle, right? So if you think of the unit circle, first of all, when will sign be negative? It's in the third and the fourth quadrant. And then also, when is it 1/2? So that's basically when you're dividing by 6. So this would be 7 pi over 6 and 11 pi over 6, right? So we're going to take the 2 theta, make it equal to 7 pi over 6. Now remember, since we have a number being multiplied with this theta, all right, you want to add 2 pi to this, or 2 pi k. It's really up to you if you want to put the k or not. So this will tell us what do we need to keep on adding to find more solutions, right? So we're going to multiply by 1/2. We need to multiply this by 1/2. 2's divide out here. We get theta is equal to, we get 7 pi over 12 plus pi, right? So our solution, theta is equal to 7 pi over 12, right? So here's one of our solutions, and let's pay attention. Let's take a look at our interval. So whenever you're solving these, you always want to make sure your answers are in the interval. So our interval is between 0 and pi. So between 0 and pi, okay? So if you go to the first solution here, so 7 pi over 12 is between 0 and pi, right? Because pi would be 12 over 12. Now, since we're adding pi to find more solutions, so pi is the same thing as 12 pi over 12. Well, if I add 12 to this, I would get 19 pi over 12, but this is more than pi, right? So we're going beyond our interval, so we don't want to count this solution, so that's too much right there. So we know the only solution we have is just going to be this, okay? Now we're going to do the same thing with the other angle, the 11 pi over 6. So we have 2 theta, right? We have 2 theta is equal to 11 pi over 6 plus 2 pi. And then multiply by 1/2 on both sides, multiply by 1/2. We're going to end up with theta is equal to 11 pi over 12 plus pi, right? So over here, we have 11 pi over 12. This is less than pi, so yes, we can include this solution. Now, if you add pi to this, obviously it's going to be way too much. It's going to go over our interval if our interval is from 0 to pi. So you don't need to add anything else to this. So these two would be our solutions for this problem, okay? All right, so let's take a look at the next problem here. So part A, right, it tells us to show that this is equal to 2 sine cosine x, all right, minus sine x. So the first thing I recognize right here is I've got this cosine double angle, right? So I know that I could use some sort of substitution there that would kind of help me and make sense. So I've got sine 2x, and I'm going to replace this cosine double angle, right, with 1 minus 2 sine squared x minus 1. And then if I take out right here this sine double angle, replace that one as well, that's 2 sine x cosine x, then I would get these ones cancel, I get minus 2 sine squared x, right? And then take out the GCF, which is 2 sine x, so that would leave me with cosine x minus sine x, which is what we were trying to show right here. Okay, so that's part A. Let's take a look at part B. So part B says, hence or otherwise solve. So we have basically 2x, sine 2x plus cosine 2x minus 1 plus this cosine x minus sine x is equal to 0. Okay, so we know that this right here is equivalent to this, right? So basically we can substitute that. Instead of writing this right here, I'm going to write this instead. So I have 2 sine x parentheses cosine x minus sine x, right, plus cosine x minus sine x is equal to 0. So basically what you kind of have to recognize here, here's where it's a little bit tricky. If you put this in parentheses and imagine a 1 right here, we kind of have factor by grouping, right? So basically I can group this and this together. So we've got a 2 sine x plus 1, and then our other factor would be cosine x minus sine x is equal to 0. All right, so that's where this one is a little bit tricky. Okay, so you have to remember kind of this factor by grouping. So now that we have these two factors, we know that sine x is going to equal a -1/2, and over here, if we kind of solve this a little bit, you're going to end up with cosine x is equal to sine x. So if you divide by cosine, that will give you 1 is equal to tangent x. Okay? So let's go to our unit circle and solve the rest of these. Now our interval, always pay attention to your interval, is from 0 to 2 pi. So 1 complete circle is our interval. Okay? So over here, where is sine negative? That's in quadrants 3 and 4. When is sine 1/2? Sine is 1/2 when you're dividing by 6. So we would get 7 pi over 6 and 11 pi over 6. Right? So we know x is equal to 7 pi over 6, right, and 11 pi over 6. Over here, when is tangent positive? Tangent is positive in quadrants 1 and quadrant 3, right? And tangent is positive 1 when we're dividing by 4. So this would be 5 pi over 4. So x would equal pi over 4 and 5 pi over 4. Okay, so that's part B.